Hello, so I'm going to be doing the titration of lysine. I did some work ahead of time, so it makes it a lot smoother. So basically, on the bottom right here, this is the chemical structure of lysine at pH 0. At pH 0. So you have this amine group attached to the alpha carbon, so that amine is going to have a pKa of 8. The carboxyl right here is a pKa of 2, so that proton will fall off first. And on the top, this amine group is going to have a pKa of 10.8. So after we go from 0 to pKa past 2, we're going to have all of the ion in form B, which is right here. Form B, the first group to lose this proton is COOH, and then the other two groups will keep their proton. Once we go to past the pKa of 8, then we know that amine attached to the alpha carbon right here will lose this proton. So then it's just going to be NH2, but the amine on top won't lose it yet until we get past the pKa right here of 10.8. Then we're going to have the D, this form is in D, where the NH2 group right here on the top will also lose this proton. So at this point, everything is fully deprotonated. So I need to do this first to then start the graph. So on the graph, we're going to go like this, down, down. On the bottom, you got moles of OH that's going to be added for this titration. On the side, you're going to have pH. So the pH levels we choose is going to be 2, 8, and 10.8, I think. What was it? Yes. And then moles of OH, we're going to see in total that since we have 3 protons that are coming off, we'll have 3 moles in total, but we go in increments of 0.5. So let's just draw the line first. So we know we're going to start here, up, 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 and then we get here, up, here, up, here, and then up. So we're going to end up like this. I also drew the graph under, so I want to peek at it real quick. Yeah, so when we're going up, we go up until we hit this inflection point right here. This is number 1 inflection point. At this point, we're going to have, let me see, A plus D. So half of A and half of B. And this is going to be at 0.5 moles of OH. And when we add 0.5 more, it's going to be right here. And we're going to be at 1.0. And this is where we're going to have only B. All the A is going to be gone, or A form of that amino acid is going to be gone. So then we add 0.5 again, so we're going to be at 1.5. At this point, we're going to have B plus C. This is at pH at 8. And we add 0.5 again, so we're going to be at 2.0 moles. We're only going to have C on this equivalence point right here. Then we keep on going, and it's going to kind of flatten out. It's a little exaggerated right here. But at this point, we're going to have C and D, so we're going to have 50-50 at pH of 10.8. And then we're going to be at 2.5 moles. And then we're going to go back up for another equivalence point, and then that's going to be at 3. So that's where we're going to end, at 3 moles of OH, or 3.0 moles of OH. So this was the first equivalence point right here. This is the second. This is the third. This is going to be, I'll do a different color. The first, no, I'm sorry. Let me erase this real quick. Yeah, so right here is your first inflection point. Right here is your second, third. For equivalence point, that's where it's going to go straight up or like more steeper. This is your first one, your second one, and your third one. And yeah, that's basically it. This is how we're going to titrate lysine based off of the groups that it has and how the protons will come out of it. So how the proton will first come out of COOH, then the amine attached to the alpha carbon, and then the top group, which is also amine, but it's a lot further away from the alpha carbon. Thank you.